Hi, for the SDN cast, we're here at Futuretech. I am here with Rendel, who just delivered his keynote. And Rendel, for the people who don't know you yet, could you please introduce yourself?
Yeah, sure. So I'm Rendel, no other, just mononym, and I am a consulting software engineer in the way that Sherlock Holmes was a consulting detective. And so I'm working with companies, doing a lot of work on modernizing legacy code, bringing .NET framework applications onto sort of .NET 8 and 9. Also do a lot of stuff with performance, improving system performance to reduce carbon footprint, amongst other things. But increasingly, I seem to be spending a lot of my time doing keynotes and speaking and showing off at conferences and events and things, and which is great. I really enjoy doing that. So, like that one just then, so much fun.
Yeah, we really enjoy you giving these keynotes because these are always awesome talks.
Thank you.
This one was about the next 35 years and what to expect in tech, right?
Yes. Which might seem like an arbitrary number, but I got my first job 35 years ago. And so the talk essentially looks at what technology was like when I started my first job, and then how it progressed up until now, like transistors shrinking on chips and all this sort of thing. And then just going, so if we then apply that to what we've got now, let's try and imagine what that'll be like in another 35 years and where we'll be as an industry, but also as a society at the end of that.
And if you look back in these 35 years, there are probably some pivotal moments, right?
Yes. So the first big one that occurred within my career was the World Wide Web. So the internet existed, ARPANET, and then it became the internet when more things joined it and so forth. But nobody really used the internet until the web came along, and then we got sort of search engines and everything else. And then I think after that it would be probably smartphones would be the next big one. It's kind of when the internet went from being this thing you had to go and sit at your computer and turn it on and log in and then some dial-up modems and that sort of thing, to this point in, only 13 years after the web was created, you could pull a small rectangle out of your pocket and browse to any of those websites and use it on your phone. So that was a very big pivotal moment. And then I think right now, I would say we're probably at another one with LLMs and generative AI and these assistants that can help us with our jobs in various different ways. If that is actually, if it's a stepping stone to the next thing, the problem with AI is they run into a lot of dead ends, and so we're already getting up to the limits of how big you can make these models, how many tokens they can handle, and so on. But if this drives the next iteration, the next innovation, then I think we are at a point where we are going to have machines that, for all intents and purposes, can think. I don't think they'll be conscious, but I think they'll be able to mimic human thought processes.
Yeah, but we're still limited probably now by hardware. And we also have the pushback, of course, because all these models are getting bigger, but they almost serve no purpose to being that big.
We're definitely at the point of diminishing returns. If you look at the investment that they're pushing for, is it like $500 billion fund that they just announced in the States, which is sort of coming from VC, but also like Microsoft and OpenAI, who are running on VC money and yet somehow are able to invest in anyway. But yeah, to build infrastructure, and I mean, it's probably 499 billion of those dollars are going to be spent on NVIDIA GPUs. And then you've got to run these things, and these are like, we're getting to 650 watt, 1000 watt GPUs now. That's a lot of energy being used to train these models, and the improvement over the previous version is becoming marginal. Yeah. And so I think we need the layering reasoning models over the top now, which hopefully will ameliorate some of the the hallucinations and so on. You can actually get the generative thing to sort of process stuff, and then the reasoning model to go, does that look right though, and kind of send it back and go, I don't think, and so on. But yes, if we can get to the next thing after the large language model and different ways of using that same data set to simulate intelligence, then I think we are at this point. And also in terms of the computing power, the other thing that I touched on is quantum computing, which for a long time now has been kind of a pipe dream, and there's a lot of problems with it. But Microsoft have just made this Majorana 1 announcement, and I've read the paper, and the 5% of it I could understand, because there's a lot of particle physics and stuff in there. But if you combine, like if they get that up to the 1 million qubits that they're targeting over the next 10 years, and then you've got a 1 million qubit quantum computer, that would be able to do that whole AI training inferencing thing in seconds.
Yeah.
And without, the majority of the power in quantum computing actually goes on the cooling, because these things have to be cooled to within less than a degree of 0 Kelvin. But even then, that's still a lot cheaper in energy terms than running 1 million NVIDIA GPUs non-stop.
Yeah, for months to train these models
as well.
Yeah, that's crazy.
Yeah.
But I got that question, I think 2 weeks ago. Are we able to train these LLMs on quantum? Because it feels like a different problem they're solving, because LLM training is really the iterations of training these models.
Yes. I don't know. My grasp of quantum computing is quite limited, but my understanding is that it can take very large data sets and produce a result in a fraction of the time that it takes conventional, classical computing. And so, you may not be able to take a quantum computer and train an LLM in the same way as we do now, but some bright spark will come along and find a way of using that quantum power to drive some form of AI.
And as you said, it's probably now down to getting enough qubits to fit the context of the data set.
And that's it. And the Majorana 1 thing is particularly exciting because it's a single unit that has its error correction is built in. The problem with most of the qubits that we have, there's things that are rings around other things and ions being held in a particular spin state and so on. But because like neutrinos can just hit them and send them off, so you need error correction, and so for every qubit you've got like 4 qubits doing error correction then that makes manufacturing really expensive. The Majorana 1 thing, it's a single qubit with a sort of gap in the middle, so the error correction is handled internally. If they can get 1 million of those onto a chip, that is going to be able to do ridiculous things in no time at all.
Yeah, that's so amazing. And it already looked so much more easy to handle than the previous iterations.
You look at the sort of current things, and you always see these like big long tower things, and there's something, and they're all sort of coming down to a point here. And it looks like something out of a sci-fi movie from the 90s. And then Microsoft have got a chip.
Yeah.
And it's just we're going to stick 1 million qubits on and it looks like an Intel CPU or an ARM CPU. If they can do that, it's the thing that people do need to bear in mind still needs cooling. So you're not going to be wearing one of these things on your wrist ever. Well, actually, I say ever. Thing is, once you've built that first quantum computer and you've got those 1 million qubits, then the modelling of quantum processes that you can do with that, you might actually be able to go, oh, here's how you make a room temperature superconductor or whatever it is we need. There's a lot of possibilities that I'm very excited about. I plan on living for at least another 35 years just so I can keep checking in on these things.
That's so cool. And of course, quantum it's amazing, but it will take some years to get there.
Yes. Yeah.
Probably 5 to 10 years, what they're saying now?
So Microsoft's roadmap seemed to be suggesting around 10 years to get to 1 million of these things on a single chip, which is not a long time at all. And when they get to 1024 on a chip, that's already useful. 1024 qubits, you can do ridiculous kind of quantum modeling, quantum simulation with that small number of
that's
qubits.
Also going to impact how we look at security and encryption. And
I mean, my friend Eli has a talk on cryptography and what that's going to look like in a post-quantum world, because a quantum computer can guess a 1024-bit RSA key in a fraction of a second, because apparently it runs in all the universes, and then it just gives you the right one. I don't know. That's scary. But then we switch to using quantum computing to do the cryptography as well as the cryptanalysis, and so you come up with cryptographic systems that cannot be cracked or cannot be observed. I saw something. There is, if you're using fiber optics, you can polarize the photons as they're going down, and the only way you can check the polarity of a photon changes the polarity of the photon, and so if somebody was intercepting the message, you would be able to tell that it had been intercepted, because it wouldn't. So yeah, but no, there's a whole bunch of things that once we get to that world of quantum computing, general purpose universal quantum computing, it's going to change medicine, it's going to change agriculture, it's going to change everything. It's probably our best hope of getting this planet to the point where it can support 20 billion people. So, yeah.
And then 10 years
still
feels like a long time at the rate where we're now going.
It will go by like that.
That's true. Yeah. But for the more short term, because what AI advancements do you see for the next 5 years?
As I mentioned in the talk, the one thing that I really want from my co-pilot, I use an app called Pieces, which has it stores context, so it has a local long-term memory, and I've got a browser plugin, so it sees all the web pages that I go to. So if I'm on Stack Overflow looking for answers, or on the Microsoft documentation for .NET, then it remembers that, and it saw that code sample, or find something in a gist in GitHub, and it's learning from that and adding to its knowledge. Also, I've just said anything on my D drive is my code, or code that I've cloned from GitHub. You can use all of that, and so it's indexed through all of that.
Yeah.
And so it's learning how I work. The only issue is that to interact with it, I have to switch to a little sidebar and type, and I want to be able to talk. I want to be able to put my headset on and just be chatting to my co-pilot, my Pieces co-pilot, and have it watching what I'm doing, and have it actually go, oh, Rendel, can you just, I think you've like pair programming.
Oh, but it can be very annoying then. If
I would definitely want to be able to turn it off. But yeah, being able to talk to it to explain problems is much, to use it as that rubber duck that you had in your opening talk this morning. I think that is somewhere that it's really useful. I think it's like having a constant pair, but it doesn't sort of eat cheese and onion crisps while you're trying to code and things. So it's almost as recall for developers, right? Yeah, absolutely. It's that external brain idea. And yeah, if you can get it to talk to me and make it so that I can talk to it instead of having to type and read, then that would make me happy for sort of the next 5 years.
Real-time models, that shouldn't be too hard, probably.
I mean, you can have conversations. There's conversational AI apps based on DeepMind and ChatGPT 1.0 and Sonnet 3.7 and these sorts of things. So yeah, hooking that into the Visual Studio Code plugin or the JetBrains Rider plugin shouldn't be too difficult. No. It's something I would expect to see probably by the end of next year.
Yeah, cool.
Hopefully.
Looking forward to it. Thank you so much for joining us and sharing
Thank you for
about AI
me.
quantum.
Thank you.
Thank you.